In this video, I'm going to be working through more area between two curves examples. I'm going to be working the problems from the online extra practice. And so I'm just going to start with the first one. Let's zoomed in here. Okay, so write an integral that represents the area of the shaded region. Okay, and so one integral. So, kind of if that's going to need to be just one, then I'm going to need to go this way. I need to have vertical rectangles, which means I'm going to integrate with respect to x. So top minus bottom is looking like, f minus g. Okay. So if I was going to write an integral, it would be the integral from -2 to 2 of f of x minus g of x dx. So in this situation, a would be f of x minus g of x, and b would be x. Okay, the next one's very similar. It just kind of looks like it's been turned on its side. But if we're going to write one integral to represent the area of the region, right, if I wanted to do it in terms of x, I'd have, this kind of curve going on. And, it might already be difficult to express that height in terms of x. But then we'd have to do something completely different here, right? We'd have a different curve going on, so it's going to be a different type of integral. So in order to write it as just one integral, I'm going to go sideways, because in this case, g of y is always going to be on the right, and f of y is always going to be on the left. Okay, so in this case, right minus left is going to be g of y minus f of y. Since our representative rectangle sits horizontally, it's going to move up and down the y-axis. We're going to integrate with respect to y. And as a result, I'm going to integrate g of y minus f of y. And I'm going to do that as y runs from -3 up to +1. Okay, so a would be -3, b would be +1, u would be g of y minus f of y, and w would be y. All right, this next one, here we've got y equals 6, y equals 2, and y equals 6 over x, which I think this is also kind of on the homework. But, it's never a bad thing to do these more than once. And I'm going to say, all right, the integral from 0 to 1 on x, okay, really what I need to figure out is, what is a? What is my integrand going to be? So if I draw a little representative rectangle, I know that I'm integrating with respect to x, so it's going to be a top minus bottom, and this would be top is 6, minus bottom is 2. Okay. So looks like a would be 6 minus 2, or a would be 4, whatever you want. And then after, this point where really what's on top changes, I'm going to have top minus bottom being y equals 6 divided by x minus bottom is y equals 2. Okay, so that would be b equals 6 divided by x minus 2. If I wanted to write one or more integrals, well, I'll actually write this out. If I was going to do this with respect to y, pretty rough sketch, but it's all right. If I want to do this with respect to y, this would probably be a little easier, right? Because I'm always going to have this curve on the right, I'm going to have this on the left. The only issue is I need to write these in terms of, or as x is a function of y. So if I've got y equals 6 divided by x, I could multiply both sides by x, and then solve for x by dividing by y. Okay. So on the right, I have x equals 6 divided by y, and on the left, I have that y-axis, which is the line where, set of all points where x is equal to 0. So x equals 6 minus y, or 6 divided by y minus x equals 0. And so I'm going to say, if I'm going to integrate with respect to y, I'm going to be integrating 6 over y minus 0 with respect to y, as y goes from 2 up to 6. Here we've got one. And I think what I'm going to do, I mean, this one, the trick is always this kind of area over here that's outside of the half circle. That is a half circle, right? Because it's the square root of 6 minus x squared. And that's the type of thing that, yeah, I've got enough room over here. Y equals the square root of 6 minus x squared. That gives you, well, first of all, y has to be positive, and that's why it's just the top half of the circle. But if I were to square both sides, I'd get y squared equals 6 minus x squared, and then you'd say, and so that's a circle that is centered at the origin and has radius square root of 6. So I know that this is root 6 and negative root 6. Okay? If I wanted to do, do this with integrals, that would be, I just don't think that's the thing to do. I think what you do instead is you say, all right, this half circle here has area 1/2 pi times radius squared. Okay? So it's going to be 3 pi. Okay, the area of the whole rectangle is going to has a width of 6 and a height of 5. Okay, up here this is not drawn to scale. And so as a result, I'm going to say, oh yeah, my area is going to be 6 times 5 is 30 minus 3 pi. And let's do this with the calculator. And I get 20.575. Okay. Now we've got one where we're going to have to find the intersection. Okay, the issue is what's that x coordinate? We don't know. That's not something that we can just solve for either, because this is like solving the equation cosine x equals 2x. I don't know about you, but I don't know any way to solve that one algebraically. So what I'm going to do over here is I'm going to find cosine of x, make sure I'm in radian mode, minus 2x, and I'm going to try to find where that's equal to 0 between x equals 0 and x equals 1. So, okay, there it is. I calculate the 0. I'd say, okay, well, okay, that's where it's positive. 1 will serve as a right bound, and then I get 0 point. Okay? And because this is not the answer, I'm not going to round it to 3 decimals, right? I need to hold on to all the decimals so that my final answer is accurate, and I can round that and not have any sort of error. 0.4501836. Okay. And right, so the area of the shaded region is going to be the integral from x equals 0 to x equals this number of top minus bottom. Now in this case, top is cosine x and bottom is 2x, so I'm going to cosine of x, write it like that. It's my height, and that's going to be my integrand as well. And since I've already got that in y1, I'll probably use that rather than trying to type that again. So I'm going to call for an integral, pressing math 9, integrate from 0 to 0.45018. Oh no, I didn't have number lock on. 0.4501836. Right, and then I will be calling for y1 and integrating this factor x. I get 0.232. Right, this one is much more algebraic. Find the value of b so that the line y equals b splits the area enclosed by the y-axis, y equals 2, and y equals square root of x. All right, I can do that. First step is going to be to draw a picture, though. Y equals square root x looks like that. We'll say y equals 2 is right there. All right, and we've got y equals b, which is going to be a horizontal line, and it's, the magic horizontal line that splits this area in half. So I bet it's going to be, right here. So the thought is if I integrate, and I'm going to need to integrate with respect to y, if I integrate from 0, y equals 0 up to y equals b on, right minus left, usually use blue for that, but I already used blue, so integrating that from y equals 0 to y equals b is going to be the same as what I would get integrating y equals b to y equals 2. So I need to just be able to write down, what is right minus left in this situation. So if y equals the square root of x, well, that tells me if I wanted to square both sides, I could say that x equals y squared. And so the width of this horizontal line segment right here is going to be x equals y squared minus the y-axis is x equals 0. So it's just y squared. So my equation that I'm looking to solve for b is going to be the integral from 0 to b of y squared dy is equal to the integral from b up to 2 of y squared dy. And now we're going to be able to solve this kind of just the old-fashioned way. Find an antiderivative. Oops. It's equal to 1/3 of y to the third from b to 2. And then I'm going to plug in those bounds and subtract. So 1/3 of b to the third minus 1/3 of 0 to the third is equal to 1/3 of 2 to the thirds minus 1/3 b to the third. Okay. So I'm going to add over that negative 1/3 b to the third right there and have 2/3 b to the third equals 8/3, which is telling me that 2b to the 3 equals 8 when I multiply both sides by 3. Divide both sides by 2. I don't know if I said the wrong thing. I multiplied both sides by 3. B to the third is going to be 4, and b is going to be the cubed root of 4, meaning the n is 3 and the p is 4. Now we're going to find the exact value of the area enclosed by x equals 0, that's the y-axis. Y equals e to the 2x. Well, that's going to start at y equals 1, and it's going to grow exponentially. I don't really care if the shape's quite right. X equals 3. We'll say maybe that's right here. And the line y equals negative 1. Maybe that'll be here. I'm going to start labeling these things. Okay, so the area of this region, yeah, okay. So I'm going to be integrating top minus bottom, because the curve is always going to be on top, and the line y equals negative 1 is always going to be on bottom, so it'll be easy enough. So I will say top minus bottom is y equals e to the 2x minus y equals negative 1. And then I will be integrating as x runs from 0 to 2. The integrand will be e to the 2x minus negative 1 dx. And then I'm going to find an antiderivative. Okay, an antiderivative for e to the 2x would be e to the 2x, but I would need to divide by 2 for the chain rule. And then I would add in x. Let x run from 0 to 2. So this is 1/2 e to the 4 plus 2 minus, well, when I plug in 0, I'll get 1/2 of e to the 0, which is going to be a half plus x equals 0. Okay? And then that would be 1/2 e to the 4 plus 3 divided by 2. Meaning that a would be 3/2, b would be 1/2, and c would be 4. Alright, this next one's going to require the use of a calculator, so I have to start. And I'm going to first, I'm going to actually find the area of this region, because I think that was a problem on there that I just didn't copy onto this little document here. So the first thing we're going to need to find is the x-coordinate of that intersection. Okay, so we're going to graph this on the standard window, and that's just not going to get it done. So I'm going to need to go maybe from 0 to 20. We need to be able to adjust the viewing window as is appropriate. Yeah, there we go. We're going to calculate the intersection between blue and red. That will be 13.229755. And, I think since I'm going to be kind of continually needing to use that number, I'm going to call that x0. Okay, just for shorthand. And I'm going to store that number into my calculator. So it's going to be 13.229755. I'm going to use the store button to store it to variable a or whatever. And you press enter, and it's like, okay, I know. When you say a, I'm going to know that means 13.229755. Okay, so we're going to find this area. Our representative rectangle will be top minus bottom. It will be red minus blue, which I think is, yeah, it's f minus g. And so I'm going to integrate from x equals 0 up to x equals a. I'm going to be integrating top minus bottom, which will be y1 minus y2 with respect to x. And that would be kind of the first part is area equals 60.1114. I remember it said round to 4 decimals. I'm realizing that I did that so that it would kick back an error if you had early rounded on this number. I remember now. I was kind of wondering, why is that one 4 decimals the rest of them? Okay. So now it's kind of moving beyond that. We're going to find the value of k for which the vertical line, which I'm going to draw in green here, x equals k divides the shaded area into 2 equal subregions. Maybe it's about like that, right? So the idea is going to be that AB is, I don't really understand. Oh, okay, I get it. All right, so the integral from 0 to k of f minus g is going to be equal to the integral from k to that number I'm calling x0. And then, let's see, there's another part of this, right? Yeah. It is known that the antiderivative of g with respect to x is that. Okay, so this one, I remember this one being very tricky for the people last year. Okay, but, you know what, I'm going to call this, oh, okay, yeah. So the antiderivative is going to be, I'm just going to call it a of x, right? And so this is going to end up being a of k minus a of 0 equals a of x0 minus a of k. So I'm going to start trying to solve at this before I even deal with what the antiderivative is, so that I can make my job easier. So I've got 2a of k minus a of 0 minus a of x0 is equal to 0. Because that's something I'm going to be able to solve on the calculator. Okay, antiderivative a of x is equal to an antiderivative of f of x minus g of x with respect to x. Okay, which is going to just be the difference in the two antiderivatives. And so I think I can find an antiderivative for f myself. That's going to be 10x minus 1/4 x squared plus cosine x. That's the antiderivative for f. Minus, well, they gave me the antiderivative for g. And that's going to be x plus e log of x plus e. And then minus x, but I'm subtracting this, so it'll end up being a plus x. And then, plus c. Right? But if you think about it, I think we're going to have, do we need antiderivative? Yeah, it doesn't actually matter because we're running definite intervals here. So I'm going to actually do that. Okay, I'm going to plug that into y3. All right, so I did it. There was a lot of typing. It's all in there. So what I'm going to do is I'm going to find out what, a of 0 and a of x0 are. So when I plug in 0 into y3, I'm going to get that. Minus negative, okay, so plus 1,718,2,818. That'll be enough decimals, I promise. And then negative of a of, y3, plug in x0, which I can calculate in those as a. And I'll get 58.393, 14499. And then, okay, that's equal to 0. Maybe I didn't need to set this equal to 0 because I just want a of k. And I'm going to have to pick this back up in a second. My class is about to start. Okay, so I'm back, and I've got all of these numbers here set up. So I'm going to solve for a of k. So it'll be a of k equals the 58 number minus the 1.718 281828, okay? And then I'm going to need to divide that by 2. I'll get 28.337. Okay. Maybe I should probably copy more decimals than that because that's not my answer. I'm looking for the value of k. 337.43158. And then I'm going to go up to y equals, and I'm going to solve where does that thing equal that 28 number. But what I'm going to do is instead of, intersecting it with y equals 28 point whatever, I'm going to subtract the 28 and set it equal to 0 and find the 0 because I know that 0 has to be happening, well, let's see, somewhere in the same interval that I've already graphed, right? So minus 28.3374315.8, and I think I might turn off these from graphing to make it go a little faster. Okay, there it is. That's where it happened. So I'm going to calculate 0. Looks like it's between 3 and 6. So I'm going to get 4.261. And that was a pretty serious problem. That's definitely more serious than, any other types of AP calculus problems you're going to see. But, you were doing the extra practice, so you wanted to see something a little more challenging. And there you have it. Okay. Now we've got what looks like the same region, but it's cut up into a pink area and a blue area. And Well, I think that I just need to find, oh goodness, I wish I had copied down the y-coordinate of the intersection when I did that. Okay, but I don't need this anymore. Whoops. I don't need the antiderivative anymore, I hope. I hope that wasn't a mistake. And so I'm going to go back to graphing these, run them into each other, and calculate the intersection. Blue, red, yes, okay. So I know that this is y equals 2.769357. And I'm going to probably store that into my calculator with B. So 2.769357. I'm going to store that into letter B. Press enter. So now it knows when you say B, you mean that. And now I'm going to get the area of the pink region. I'm going to be integrating from 0 up to that number I was calling x0 earlier that I think I have stored in A in my calculator of top minus bottom. So that's going to be f of x minus 2.76937 dx. And so I'm going to integrate math 9 from 0 up to x0, which I'm hoping is stored in A. y1 minus b dx. Let me just scroll up and make sure. This problem x0 is 13. Yeah, okay. I'm just going to trust that I have that stored in A. Yeah, okay, cool. Okay, so that means that the area of the pink region is 51.691. We can do that. That wasn't so bad. Okay, using a calculator and an integral with respect to x, the area of the blue region is, okay, well, the area of the blue region, I'm going to do pretty much the same thing. I'm going to integrate from 0 up to x0, the special x value that I have stored in A in my calculator, of top minus bottom. Well, that's top is 2.7, and bottom is the blue curve, which I'm calling g of x. I'm going to integrate that with respect to x, so I'm going to 9 from 0 up to the special x coordinate, which I have stored in A. Top is y equals b, bottom is y equals g of x, which is y2. Okay. And I also know I'm good to go because I'm pulling back a positive number here. That's a good sign. If you're getting a negative number for these, that's not a good sign. It's probably a sign that you've got right and left or top and bottom mixed up. So this is 8.420. And that's, oh, okay, and then write an integral with respect to y that gives the area of the blue region. I'm going to actually just kind of replicate the blue region. And did it go through the origin? No, it came from about there. Okay, that's the blue region. And maybe I could even, right, now it's shaded blue, so it looks the same. So this is y equals log of x plus e. So we need to get this as x as a function of y in order to get this worked around for negative y. Okay, so I take e to both sides power, and I get x plus e on the right side. And I solve for x by subtracting e from both sides. Okay, and I get negative e plus e to the y. Okay, right minus left is just going to be x equals negative e plus e to the y minus x equals 0. And well, I'm just going to integrate from, well, I'll deal with the y bounds later. Negative e plus e to the y is my integrand. My lower bound of integration is going to be, well, it's going to be y of 0. So it's y equals the log of 0 plus e. That's going to be 1. And then the upper bound is going to be that, what is it, that 2.7693357. Okay, that's how. And And that's the last problem. So I think that's going to be all I got for us. Thanks for watching.
Why